Here's the second example of the writing a chemical equation topic from a description of the reaction. So what is the description of this particular reaction? Well, we have solid potassium chloride is obtained by the reaction of solid potassium and chlorine gas. Write the balanced chemical equation for this reaction. So we need to make sure that we clearly separate our reactants from our products here. And we also need to know what the chemical formula for each of those substances are, the reactants and products. In the first video, I do this a little bit more slowly, and I walk through how to get the exact chemical formulas. I'll move a little bit more quickly in this example. So what are our, let's start with our reactants. Again, if I read it, it says solid potassium chloride is obtained by the reaction of solid potassium and chlorine gas. So this must be our product. How do I get this? By reacting solid potassium and chlorine gas. Those are our reactants. So my first reactant is solid potassium. Potassium. It is not a monodiatomic element, so it's just K. And I need a subscript there of S because it's solid elemental potassium. I have another reactant here, and we separate our reactants with plus signs to show that they are separate substances reacting with each other. So that would be a plus sign there, and I have chlorine gas. Now, I cannot just write Cl because chlorine is one of the 7 diatomic elements. Hydrogen, fluorine, chlorine, bromine, iodine, oxygen, and nitrogen. 1, 2, 3, 4, 5, 6, 7. As found in nature, in their naturally occurring most stable state, these elements here are monodiatomic elements, or diatomic elements for short. They exist as molecules of 2 hydrogen or 2 fluorine or 2 chlorine atoms covalently bonded together. So because chlorine is one of these 7 diatomic elements, we need to write it as Cl2. It exists naturally as that, and it is gas. Okay? So what is our product? Solid potassium chloride. Potassium chloride, an ionic compound, will have the chemical formula of KCl, and it's solid. All right, so I know that this compound needs to be neutral, and the charge of potassium is +1, charge of chloride is -1, so the ratio of each should be 1 to 1, so I know that is correct. So let's read our chemical reaction and see if it matches our written description. Solid potassium chloride, there it is obtained by the reaction of solid potassium, and chlorine gas. Solid potassium chloride found by reacting solid potassium and chlorine gas. Perfect. So the last thing to do is to make sure that this is balanced. So let's check. The kind of atoms present are potassium atoms and chlorine atoms. Let's do an initial count. On the left side, I have 1 potassium atom, and on the right I have 1. On the left side, I have 2 chlorine atoms, and on the right I have 1. There's a problem. Chlorine is not balanced. So how do we balance it? We change the coefficient. I'm going to change this coefficient to a 2 because it will now make this a 2 instead of a 1. So when you change the coefficient, you have to stop, recalculate. This is now 2, but that is also 2. Okay? So what do we do now? Well, I need to go back and make potassium balanced. Now, chlorine is balanced, but potassium is unbalanced. Easy to do because I have pure elemental potassium there. How do I fix it? I place a 2 here. So if I place a coefficient of a 2 here, if I recalculate, this now becomes a 2. So if I look at it, Potassium is balanced. Chlorine is balanced. Everything is perfect. And my balanced chemical equation would look like that with the coefficients of 2. What would be the coefficient here? If there's nothing there, it's assumed to be a 1 and coefficient of a 2. Also, my chemical formula are correct. So you'll have a very hard time balancing your chemical equation sometimes if your chemical formulas are incorrect. So if I had not put Cl2 here but Cl, well, these coefficients would look different than what they are here. So before you balance it, you need to ensure that your chemical formula are also in fact correct.